much Spanish, I know. My apologies. But I'd like to talk to you today about some of the things that we are doing at NASA Ames, and particularly the opportunities and programs that we are developing and are ongoing for work with the Mexican Space Agency as well, particularly with students and the scientists. If I could have the next chart. Let me tell you a little about NASA Ames. NASA has 10 centers, of which we're only one, although we think we're the best one. But a little history for NASA. Prior to 1958, the United States had an organization called the National Advisory Committee for Aeronautics. It was founded in 1915. The United States Congress had appropriated $4,000 US. Our budget has grown somewhat since then. But soon after that, they established a research center, Langley Research Center, which is in the state of Virginia, near Washington, D.C. However, for the next 20 years, there were people at Langley that were radicals. They had new ideas. And so the second center was founded in 1939. That was the Ames Research Center. And we were there to help develop U.S. industry. Much of the U.S. aviation industry was on the West Coast. Shortly after that, a new center was set in the center of the United States in Cleveland, Ohio, which was the Lewis Research Center. It's now known as the Glenn Research Center, named after John Glenn. And then in the mid-40s, a flight research center in Southern California, the Dryden Flight Research Center. Since the founding of NASA, an additional 6 centers have been opened. I won't talk about their work because I think ours is better. But seriously, we work together. Next chart, please. We are very proud of our history. Most of the pioneers in aviation, space, and technology have visited or worked with us at NASA Ames. Indeed, the site itself was chosen by Charles Lindbergh in the 1930s. Orville Wright, in 1947, actually came and spent a few weeks working with us. Most of the rest of the major players have been involved with NASA Ames, and that's why we are so anxious to have the future leaders of aerospace in both the United States and Mexico work with us. Next chart, please. Now, this is an aerial view of the Ames Research Center. We are located in the San Francisco Bay Area, close to San Jose. We're on the south part of the San Francisco Bay. The site itself was originally a military base. Since that time, we have taken over the whole area. Is noted, we have about 2,500 employees and a budget of slightly more than $900 million US. Next chart. Now, we have at Ames many of the leading facilities in the world and in the United States. We have the world's largest wind tunnel that is operated jointly by NASA and the U.S. Air Force. We have many of the simulators that can simulate air and space operations. We have an airborne aircraft, or airborne observatory. It has just started operations called Sophia. It's a 747 that has been outfitted by the German Space Agency, DLR, with a telescope. And indeed, I show this because this is an example of where two countries together can do magnificent work. This is an astronomy platform. So we hope in the future to develop concepts like this involving air in space with Mexico. We are also the lead for information technology. We have one of the world's largest high-speed computers, the Pleiades, We have just worked jointly with the Google Corporation, which you might have heard of. It's a small company, but they're right next door to us, and they've been very helpful. They have more money than the U.S. government now, so they have helped us by working with us to buy the world's largest quantum computer, which is the next big step. Indeed, much of that time will be available for scientific researchers. So as we work with you, scientific researchers in Mexico will have access to the quantum computer. Next chart. Now, the other thing that we're very proud of, and this is an example of where Mexico already is working with us, is global virtual institutes. About 20 years ago, we formed the Astrobiology Institute, which is designed to study both astrophysics, planetary formation, and biology to understand how did life begin on Earth, where else is it in the universe, and maybe most importantly, what is the future of life. And there is a Mexican partner of the Astrobiology Institute that has been working with us, and there are members from many universities and researchers in Mexico. There are another 12 international partners in this institute, so we're very proud of the global nature. They've developed global connectivity, so they have virtual conferences that involve people from around the world. The good thing about it is everybody can be involved. The bad thing is sometimes you come to a conference in the middle of the night, so. But it's working. About 6 years ago, we formed a new institute called the Lunar Science Institute. A few months ago, we expanded that to the solar system, and it's called the Solar System Exploration Research Virtual Institute. We hope is research into the objects in the inner solar system continues, particularly asteroids, as well as the moon, that Mexico will be interested in joining that. Our newest institute is an aeronautics research institute. One of the very exciting opportunities for all of us, I think, in North America, is that in the next few years we are going to be transitioning from current aviation to green aviation, airplanes that may eventually be powered by electric motors, and a very exciting area. Indeed, we've worked with a number of partners, and there'll be a lot more on this, on airships. You know, things that we did in the 20s and 30s, and in the future you may travel around Mexico and the United States and Canada on airships. Very exciting area. Next chart. Now, one of the things that that we share also with the Mexican Space Agency is our interest in developing new industry. Being in the center of Silicon Valley, this is a very important mission for us. So we have a research park associated with our center, which has almost 100 partners in it. Many of these are startups that are based on NASA space and aeronautics technology. In fact, one of the collaborations that was started 20 years ago is developed into a company called Bloom Energy that developed fuel cells for power that provide clean, modular power for companies and eventually for homes. They now have over 3,000 employees and are making over $1 billion US. Very, very proud of this collaboration. We also have in our research park a number of universities, the University of California, Foothill De Anza, Carnegie Mellon University, and soon we'll have the University of Cincinnati. We also have a rather interesting new type of university called the Singularity University, which is looking at exponentially growing technologies in information technology and biological technology. Very exciting opportunity. They have about 9-week summer sessions. I would urge a number of you that are interested in these fields to apply for them. They have financial aid and so forth. Very interesting possibilities. Next chart. Now, as I mentioned today, we are actually one of the few centers in NASA that is growing. A lot of it is due to our partnerships. Now, I won't go into a lot of details of the work, but we are involved in every major area that NASA works on. We're probably unique in that capacity. Most of the other NASA centers focus on just one area, but partly because we're in Silicon Valley, we cross many different areas, and it makes it a good opportunity for students and researchers interested in not just one area to work with us. In science, for example, we have major programs in space sciences. I'll tell you about some of those areas. We also do a lot of work in earth science, particularly in understanding the impact of climate change on the environment and hopefully eventually on local environments. We have something called the NASA Earth Exchange. I would urge you to look at their website because there is real opportunities with that. We are the lead for fundamental biology. We are finding increasingly that biology is as important as aerospace and aeronautics for our activities. We are, as we speak, building biological research tools that will be launched to the International Space Station, including the first rodent habitat. I asked them what kind of rodents, because I had in mind some of my staff, but they're actually rats and mice. So. We also are a lead center for exploration technology and systems, things that support human exploration. We are the lead for entry, descent, and landing. And I like to tell people that if you want to go to space, you go to the Marshall Space Flight Center in Alabama or the Stennis Center in Mississippi because they do rocket engines and rockets. But if you want to come home, you have to talk to us because we know how to get you back in the atmosphere. Indeed, we've developed the heat shield material and tested it for all of both the governmental systems and the private systems that are being developed. As I mentioned, we have the supercomputing facility, but we also work on human factors, how to interface people with machines. It's a very exciting effort. Aeronautics and aviation. Our original mission, I mentioned green aviation, but perhaps the most important thing is we are doing the research for the next generation air traffic control system. We expect to see a tripling of air traffic globally, and we need new automated systems. In fact, that's one reason we're using the quantum computer. So again, that's an area that with a lot of potential joint collaboration. We also are the lead for aviation safety, data analysis, a very important area. Probably the most interesting thing, and the one that I am personally most excited about working with Mexico, is small satellites. Large satellites are managed generally out of the Goddard Space Flight Center in Maryland or the Jet Propulsion Laboratory in Southern California. But Ames is the lead for small satellites. In fact, in the last 2 days, we have launched 5 small satellites. We haven't communicated with them yet, so I'm hoping they're working. But these were very small. In fact, one of the interesting things, and I'll talk a little more about this, is that about 3 of them are powered by commercial smartphones. Now, this happens to be an Apple product. We haven't put Apple products up yet because Google is right next door and they give us free phones, so they are Google smartphones. But I have volunteered to work with Apple to put their phones in space. We have satellites, and I'll talk about some of these as we speak. We have a satellite in orbit around the moon. We have another one that we're working to land on the moon. But probably the most important thing, again, is our partnerships, our innovation. We are part of Silicon Valley. In fact, indeed, the fact that Ames was there was part of what led people to come and start industries in Silicon Valley. So we're very interested in entrepreneurial efforts and international collaboration, as I'll talk more about. Next chart. Now, I have a half-hour presentation on each of these, but I'll skip that. We've been around for over 70 years. In fact, next year is our 75th anniversary. We've been involved in virtually every development in aviation, including rotary wing aviation helicopters. As I mentioned, we have NASA's primary wind tunnel facilities for testing and the supercomputers to do the analysis. We developed the concept in the 1950s of blunt body reentry, that it used to be people thought that the way to get in the atmosphere was to have a very needle-nosed object. We found in the 1950s, no, you wanted a very blunt object. So virtually every reentry vehicle is based on that technology. We have a long history of small missions. The pioneer missions were started at Ames, but more recently we've gotten involved in a lot of missions that I'm very proud of. One of the really unique missions that I won't talk much about is Kepler. It's a mission that was launched about 4.5 years ago that was an Ames concept, and it was jointly managed by Ames and the Jet Propulsion Laboratory. But it is looking for planets like the Earth around other stars. Just 2 weeks ago, we had a conference where it was announced that we now believe that 1/4 of the stars in the galaxy have a planet like the Earth in the habitable zone. That is something like 10 billion planets like the Earth in our own galaxy, and there are probably 10 billion galaxies. So very exciting area. The next step is to see if any of those have life. Indeed, we're working on that. We've had a number of small satellite missions. I'll talk about some of those, and we're doing a lot with really small satellites. Next chart. Now let me talk about the small satellites. We hadn't done a lot of satellite work really since the 1990s, but when I got to Ames, we were assigned the mission to look at very small missions. We came up with a program I'll talk about a little more called LCROSS, the Lunar Crater Observing and Sensing Satellite. A very successful mission. It actually ran into the lunar surface, so quite an interesting mission. In fact, virtually all of my lunar missions end up running into the surface at high speed. We have today the LADEE mission, the Lunar Atmosphere and Dust Environment Explorer. I'll talk a little bit more about that. We also have a solar physics mission called IRIS, the Interface Region Imaging Spectrograph. I'm very personally happy with that because I'm a co-investigator. There's all this data collected, but I'm way behind in looking at it. So, so when I cease being the director, I'll have something useful to do. We are also involved in some new missions. TESS is a mission to follow on to Kepler to actually see if we can find planets like the Earth around some of the nearby stars. Kepler looked at a more distant part of the galaxy. And then we have another mission that's going to land on the moon, and I mentioned this and I'll talk more about it because we are looking for international partners to work with, so that I think there's an opportunity that we would very much like to talk with the Mexican Space Agency. Next chart. We have a video here of the LCROSS mission. So this is kind of an exciting mission. It was about 4 years ago. It actually ran into the lunar surface, crashed into it to blow material up to see if we could find ice. It was the secondary mission, which meant the primary was a Goddard satellite. Very interesting because it proved that at the poles of the moon there is a lot of water and other material, so when eventually people established outposts on the moon, the resources are there to support it. Very exciting mission. It was a very low-cost mission. It cost about $78 million US. which for an interplanetary mission was very good. And it was a secondary mission, which meant that the primary mission paid for the rocket, and so we were able to ride along as a secondary. So again, very exciting mission. Now, I do have to say that it was mentioned that I was a U.S. Air Force general. I did make the mistake of saying this was the first bombing run on the moon, but I got in trouble for that, but it was a very accurate bombing run. We hit within 100 meters of our target, which is pretty good at you know, hundreds of thousands of kilometers. But again, a very exciting mission that showed what we can do with low-cost interplanetary missions. Next chart. Now, this is the solar mission. We'll talk a little bit about it. It is studying the region between the where the sun's surface temperature is about 6,000 degrees centigrade. It lowers to about 4,000 degrees, and then it rises to 1,000,000 degrees. But this is the launch. It was launched on an air launch booster, the Pegasus booster, this last summer. The satellite then goes into orbit and is now studying the sun. So again, a very exciting mission. Lots of opportunity. Just this week, we have opened it up for guest observers so that solar physicists throughout the world can actually apply. A lot of international collaboration. This was done in concert with the Lockheed Corporation. Another partner we have on one side of Ames is Google, on the other side is Lockheed's space division. So it's a good place to be. And we work very closely with both of them. But I do want to emphasize, again, for the United States as for Mexico, working with industry and developing industry is really a key requirement, and it helps get our political support. This again is a small satellite. This was a $125 million satellite. Most of our science satellites cost hundreds of millions, if not billions, but very, very impressive instrument. It is also an international collaboration with significant cooperation with Norway and the Netherlands. Next chart. So this is again is a little bit of information about the mission, but a very typical mission where partnerships are the critical element. Next. Now this is LADEE, which was launched on September the 6th. We actually put it in lunar orbit on October the 6th, was when the U.S. government was shut down. So I'm very impressed in what we can do when nobody's working. But we were able to have to get dispensation to get them to allow us to operate it. Oh, you got the. They got the wrong video or audio on that. That's the YouTube video. It's the only way we can get access to information is to go on YouTube. So do you have the LADEE one there? We launched this on a refurbished intercontinental ballistic missile, a Peacekeeper. It was launched from Virginia. It was the first deep space mission to launch from Virginia. And you could see it from Washington, D.C. and New York City. And as a military officer, I never thought I'd see an intercontinental ballistic missile fly over Washington and New York and think it was a good thing. Okay? Does it have any audio on it? Or? What we're looking for with LADEE is the residual lunar atmosphere. We're always taught in school the moon doesn't have an atmosphere. In fact, it has a very thin one. It's called an exosphere. During the Apollo program, we discovered a couple things. One is that every time we landed an Apollo spacecraft, the density of this atmosphere doubled, and it stayed that way for months. We also, some of the astronauts thought they saw what looked like dust storms on the moon, which would be a very significant limitation if we have activities there and bases, if there's actually dust raining down. So this mission is designed to go and study that. Now, it was important to study it before somebody comes and lands again and human activity starts to ruin the environment. And it turned out this was very timely because it's in orbit now, taking data. And in about a month, the Chinese are going to land their first lunar lander. So we'll be able to study it both in its pure state and then when it's been disturbed by a spacecraft that we will know a lot of information about. So this is an example of international collaboration that wasn't intended, but is actually quite good. But again, the spacecraft is in orbit around the moon. This was also a low-cost mission. It was about, including the launch vehicle, about $200 million US dollars. So again, very exciting, and one that demonstrated a couple things. Its key design was what's called a modular bus. Much as your desktop computer, you don't replace the whole thing. When you need a new one, you just pull on a module, whether it's more memory or more capabilities or read-write. So this was designed in modular areas. We think that the next one may end up going to Mars or could be used as a communication satellite bus, but very interesting technology development. Next chart. Now, we also do entry, descent, and landing, so I have a short video here of some of our heat shield development of next generation heat shields. We always put interesting music on these. This is a test we're going to be doing in a couple years of a new kind of heat shield that can get us much more effectively into atmospheres like Jupiter or Mars or Venus, or bring things back to Earth. This is an example of what we would do with Mars. It's the next step beyond the Curiosity sort of sky crane that so we can get larger payloads onto the surface of Mars. So I don't know why they play this music, because if you're in space, nobody can hear you. One of the interesting things we're doing is to get better heat shield material. We are actually weaving together carbon fibers. So it's really the next generation of material for heat protection. Next chart. So again, it's a deployable heat shield, and one of our problems today is that the heat shield is only the size of the spacecraft. This gives you a bigger area so we can bring bigger payloads into an atmosphere. Next chart. And this is a technology development. I show it again as an example of research and research opportunities. This is one that we certainly would welcome participation from you. Next chart. Now, the next mission to the moon that America is going to do is to actually land a small robot that will drill down into those areas near the poles of the moon where we think there is ice. It's called the Resource Prospector mission. This mission, again, is designed to be a low-cost mission. The U.S. is probably only going to put something like 150 million. The only way we could get our White House to let us do this is we promised we would do international cooperation. So we'll be talking to you about it. But we've been talking to a number of countries, Canada, Japan, South Korea, as well as the Germans. So there's opportunities for instruments, there's opportunities for scientists, but we plan to land in about 2018. So I think a very interesting international program. Increasingly, we will see these planetary missions be done internationally. Next chart. Now, let me get to what I think is most interesting, is the nanosatellites. And 15, 20 years ago, when they were first developed, and they were actually developed mostly in England, they were just toys. And the concept was, a few years later was come up with by a Stanford professor that let's just build a cube that's 10 centimeters square, weighs a kilogram, and see what we can do with it. And those are CubeSats, and those have now become an incredible opportunity. So we have adapted the CubeSat concept to do a lot of missions. We first did biology in space. You can do fundamental biology. And then we figured out, as I mentioned, that you can use commercial electronics. In fact, 2 of the satellites we launched a few months ago cost $4,000 US for the parts. So we're getting into a price that I can afford. President Obama visited Ames briefly, and I told him about this, and he said, "Good, then I can cut your budget." So you have to be careful when you show politicians how cheap you can do things. What we're working on now is launching these from the International Space Station. And this is a very exciting opportunity because it is an International Space Station. Everyone has access to it, but the satellites go up as part of the luggage. You know, when we resupply the station, we put these CubeSats, they're just kind of tucked into the corners, and then they're taken by the astronauts and put on a launcher that is a commercial launcher, but it's hosted on the Japanese module. And then a few weeks or months later, these can be launched, and a very, very low cost, very exciting effort. This morning, we just launched one that'll be the first attempt to re-enter a small payload from the International Space Station. You might have seen me looking at my iPhone to try to figure out how that was doing. So it was ejected all right. We're still waiting to communicate with it. But we have a lot of new missions. I'm going to talk a little bit about some of these, but one of the very exciting things is clusters of these small satellites that can do amazing research that in the past you required big satellites. Next chart. The first one was launched, I said, about a year ago. It was called TechEdSat, and this was a classic collaboration. It was done with the private sector, with NanoRacks. It was done with Sweden, again, a country that's starting to do more in space, but has a lot of interest in high technology. And it was launched on the Japanese resupply mission, so truly international. I did get in a little bit of trouble. I talked this morning with your colleagues here where I said that it's sometimes better to beg forgiveness than permission. But headquarters didn't realize that we had done this international mission until it was already on the launch pad. And so they quickly had to do the paperwork. And I was lectured by the administrator on, I said, well, it's just a little thing. But very successful opportunity to do exciting science very quickly. We think we can develop and launch these things from the International Space Station in 6 months to a year. So it's perfect for student projects, for dissertations, and studies. Next chart. This is an actual picture of the deployment of those 3 little CubeSats so it's the smallest thing we do in space in concert with the biggest things we do in space. And this looked like an artist picture, but it's actually a real picture. There's I think, was there a video on the, yeah. Next.
We are trying to re-enter with these payloads that can re-enter to the Earth's atmosphere to bring payloads back from the International Space Station. But to make it possible to do really small payloads, we can go to Mars, where the total cost of a mission to Mars or the Moon or Venus or to an asteroid may be a few $1,000,000. So this is another area we'd like very much to talk to you about, doing missions to asteroids, for example. Next chart. Again, I mentioned that we've gotten a lot of attention, that mostly people look at NASA and say you do these things that cost billions of dollars. I mean, the International Space Station cost $100 billion US. Well, now we're doing things that cost thousands of dollars, and it's a revolutionary change. Next chart. The other thing that we're developing is how to deploy these things is secondary payloads. Every booster around the world that goes up has tens to hundreds of kilograms of spare mass that, indeed, today they put pieces of concrete. So it's launching, junk into space where we can actually launch science. So 2 days ago, on, again, another refurbished intercontinental ballistic missile, we just tested this thing, which was called the launch adapter, where we launched something like 32 satellites in about a half hour from this launch adapter. So this is really changing the way people think about space. It used to be expensive, now it's cheap. Next chart. The next step, as I mentioned, was to have constellations of these. This is going to be launched this next summer. It's called the Edson mission. It's going to do space weather studies, but there are 8 of these satellites that will all talk to each other. And so it's a cluster of satellites, and this is another great opportunity to eventually build networks. We're looking at these kind of concepts to do Earth science. So we have global networks all interlinked with these very small, low-cost satellites. Next chart. Now, this is a very exciting program, and this is one that I hope is some of the students that are working with us will get involved with. This was originally a U.S. Defense Department project to build little robots. And these are robots also controlled by smartphones. I think in this case they do use an iPhone. But they're on the International Space Station, and we're developing them to work with the astronauts so that the astronauts can send these things eventually outside the space station to inspect things and to construct things. One of the very exciting areas in robotics is human-robotic interface. As we said, we will go into the solar system hand and claw with robots. But these are on the space station today. There are a lot of student projects involved with them, and we invite you to participate with us as well. Next chart. Now, I really want to emphasize international partnerships. Ames has over 50 partnerships. We do more international partnerships than any other centers, and we are particularly eager to work with Mexico. The partnership between the United States and Mexico, as discussed earlier, is growing and very important to both our economies. So we invite you to participate even more closely with us. But we are mostly at Ames working with non-traditional partners of NASA, including countries like Lithuania, that was about to launch some CubeSats from the International Space Station. A few years ago, we weren't working with South Korea. Now we are. The South Korean president announced a few months ago, based on that collaboration, that South Korea was going to launch a robot to the moon and land on the moon by the end of the decade. The head of the South Korean Space Agency, who actually got his doctorate at the University of Texas, came to visit me, and he said, it's really nice when the president says that, but now the question is, how do they do it? And so they're asking us to work with them, so another set of opportunities. And these collaborations can be technical, or they can be educational or scientific. Next chart. Now, again, we're very anxious to expand the collaboration. An agreement has been signed between NASA and the Mexican Space Agency that gives us the framework to do a lot of projects. Particularly what we've been doing so far is hosting student researchers, and this has been very, very exciting. In fact, I'll show you their names here in a minute. But we'd like to expand that to do more technology development programs, both in aeronautics and space. Next chart. This is a list of the students in 2013. I think we had 22. Several of the students that have been at Ames this year and last are here. Could you stand up? And I think a couple of them are here. Yep. And thank you. We're going to go to the stars together. Next chart. 12 of the students focused on aeronautics. It's very important to understand that it's not just space, but aeronautics research, including telerobotics, the ability, again, to interface humans with robots, which is a big growth area for all of us. Next chart. This is a very exciting project. This will be launched this summer. This is CICYTA-1. That's being worked with the California State University, San Jose, as well with a number of Mexican universities and the private sector to launch from the International Space Station. Again, very exciting project. And it's going to do studies with Globalstar, communicating with the commercial communication systems, so it links small satellites with communication. Also, there's going to be tests on new electronic material, graphene. So very exciting set of research. Next chart. We have a short video about the Tech EdSat and AzTechSat. So there you can see that's the actual picture of them being launched. So this is a good example of what we can do, and this next summer we're hoping to have another large group of students from Mexican universities to be working with us. We're also working on rocket launch. You saw some of the pictures earlier where a number of the students from Mexico designed and launched a small rocket. So another opportunity to do fun things and also help develop new industry. Next chart. In fact, there's a video here of the... That's the really cool part. Especially when they work. They're kind of exciting when they don't work and they blow up, but that's a... Finding the payloads before, you know, rabbits or something do. But we're looking forward to do a lot more fun things. Next chart. Now, we really are looking forward to working with you. The process for applying is through these websites, and the Duarte Carlos at the Mexican Space Agency is the point of contact, and so we're very anxious to have more students at Ames, and from those collaborations we will be on Mars and beyond. So I'd really like to thank you for the growing partnership, and we're looking forward to a wonderful journey to the stars. Thank you.